Let's take a look at some applications involving systems of equations. Our first example, find two numbers for which the sum is 93 and the difference is 9. So we have two unknowns because we have two numbers. So the sum, that would mean addition, x plus y must equal 93. And their difference is 9, so we would have x minus y must equal 9. Now here's our system of equations. Remember, we have a variety of methods for solving this, but what stands out for me is the elimination method. If we were to add these two equations together, notice the y terms are opposites. This would simplify to 0. Therefore, if we add x plus x, we'd have 2x. 93 plus 9 would give us 102. This will allow us to easily solve for x by dividing by 2. X is equal to 51. Now in order to find the other number, we need to substitute x equals 51 into either of these equations. I will go ahead and just use the first equation. So since x is 51, we can solve this equation for y by subtracting 51 on both sides. And we can see here that our second number will be equal to 42. So we can say the two numbers whose sum is 93 and whose difference is 9 would be 42 and 51. Let's take a look at another. The perimeter of a rectangle is 160 yards. The width is 4 more than half the length. Find the length and the width. So let's let x equal the width and y equal the length. Let's label our rectangle. I'm going to label this y for the length and this x as the width. So the first sentence states the perimeter is 160 yards. So remember, the perimeter is a distance around the outside. So the perimeter of this would be 2x plus 2y must equal 160. The second sentence states the width is 4 more than half the length. So the width is 4 more than half the length. When I read the width is, that's telling me that I'm going to have an equation in the form of x equals. Since y is the length, to express 4 more than half, I'll start by finding half of the length. That would be 1/2 y. But since we want 4 more than that, I'd add 4 to that. Here's our system of equations. The method that sticks out here for me would be substitution, since this is already solved for x. So wherever we see an x in the first equation, we can replace it with 1/2 y plus 4. So let's go ahead and do this substitution and then solve the resulting equation. So we would have 2 times, instead of x, 1/2 y plus 4 plus 2y equal to 160. Let's distribute and solve for y. We'd have y plus 8 plus 2y equal to 160. So we'll combine our like terms and then subtract 8. So that would give us 3y. If we subtract 8 from both sides, that would leave us with 152. Dividing by 3, y would be equal to 50 2/3 yards. Now we're not done, we still have to find x. But over here we have an equation that relates x to y, so let's go ahead and use this. X is equal to 1/2 times y plus 4. Since this is in fraction form, I'm going to go ahead and use the fraction form of y, or 152/3. Simplifying here, this changes to a 1, this changes to 76. So we'd have 76/3 plus 4. Well, 4 is the same as 12 thirds, so we'd have 88 thirds, which is equal to 29 1/3 yards. Let's go ahead and write this one more time to clean it up. We know the width now, which is x, equal to 29 1/3 yards, and the length, or y, is equal to 50. This one's a little more involved because of the fractions, but I don't think it was that bad. What we could do is replace x and y in this first equation to make sure that the perimeter still would be 160, so I'm going to go ahead and do that. We'd have 2 times, remember that 29 1/3 was the same as 88 thirds, and 50 2/3 was the same as 152 thirds. This should give us the perimeter, which they stated as 160, which verifies our solution is correct. Let's go ahead and take a look at one more. Sunset rents an 18-foot truck for $49.95 plus 75 cents per mile. Cactus rents 18-foot van for $59.95 plus 50 cents per mile. For what mileage is the cost the same? So we're going to have two cost equations, one for Sunset and one for Cactus. For our first equation, the cost, C, is equal to $49.95 plus 75 cents per mile. So we have a fixed cost of $49.95 and a variable cost of 75 cents per mile. So if we let x equal the number of miles, the total cost for the Sunset truck would be, now we need to be a little bit careful here, this is in cents and this is in dollars, so we're going to convert 75 cents into dollars, so 0.75 times the number of miles plus the fixed cost of $49.95. Now if we go with the 18-foot van from Cactus, the cost is going to equal 50 cents per mile, so 0.50 times x plus the fixed cost of $59.95. So there's our system of equations. The question asks, for what mileage is the cost the same? So we're trying to find the values of x and c that satisfy both equations at the same time. Again, we can solve this using a variety of methods, but what sticks out for me is substitution, because both equations are already solved for c. So since c is equal to this in the first equation, we'll place the c in the second equation with this expression and then solve by performing substitution. So the result would be this equation. Now, as before, if we wanted to eliminate the decimals, we could multiply through by 100. I'm not going to do that here. I'm just going to solve by isolating x. So I'll subtract 0.50x on both sides. And I'll be lazy here and also subtract 49.95 on both sides. Notice I have performed the same operations on both sides of the equal sign. So when we combine the x terms here, we're going to have 0.25x. This simplifies to 0, that's why we did that. This simplifies to 0, that's why we did that. And then lastly, it looks like we have 10. So now we can just divide by 0.25. X is equal to 40, or in this case 40 miles. The rental cost will be the same when the mileage driven is equal to 40 miles. I hope these examples were helpful. Thank you and have a good day.